All right, starting in a new chapter, chapter 5, we're going to be talking a lot about quadratics in this chapter. So we're going to start off by graphing some quadratics. There is a video about how to make sure that you graph quadratic and find some different things with it. Please make sure that you watch that. So we're going to graph the quadratics, and then we're also going to find values from the quadratic graph. We're going to talk about the maximum and minimum, the domain and range, the vertex, the axis of symmetry, and the direction of the graph. So we've got a bunch of different things that we're going to talk about and how to find them. None of them are necessarily too difficult, but it is what we're going to do. We'll also find the intercept, the x-intercept. All right. So first term that we're going to talk about is a quadratic term. That's what's with the x squared. The linear term is the x term, and the constant term is the number term. Axis of symmetry is a line in the graph line where the graph is a mirror image of itself on both sides. This axis of symmetry always goes through the vertex. So the vertex is always on the axis of symmetry. The vertex is the highest or lowest point in the parabola. The maximum value is the biggest y value for the graph, and the minimum value is the lowest y value for the graph. Again, those are y values, not x values. The vertex is the ordered pair. That's either the highest or the lowest point, but the maximum value is just the y value, or the minimum value is just the y value. But the vertex is an ordered pair. All right, so a quadratic graph is in the form of y equals ax squared plus bx plus c. So this is what we were talking about, the quadratic term, that ax squared. This bx is the linear term, and the c is the constant term or the numeric term. To find the y-intercept, we just find that c value. So the intercept is just here at the c, the last value, because we put zeros in for the x's, and obviously those would cancel out. Now there is a formula for the axis of symmetry, x equals negative b over 2a, where b is the number of the x, the linear term, and the a is in front of the x squared, and notice it's a negative and the 2 is part of it. So because that's the axis of symmetry and it's a vertical line here, and I told you the vertex is always on the axis of symmetry, the x value for the vertex would also be the same value here, that negative b over 2a. So we can always find that algebraically. We can also use our graphs to find it. We'll talk about both of those abilities in just a minute. So that's some of the information that we talked about. What about some other? Again, the basic form. When does the graph open up and when does it open down? It opens up when a is greater than 0. So this first value is the value that's important. It's what's called the leading coefficient. The leading coefficient is always important in terms of which direction our graph goes. So this is a maximum. This has the maximum, and a maximum occurs when we have a downward upside down u. So the vertex is here and it's a maximum. And we have a minimum when it's a normal u. So a is positive, gives us a normal u. A is negative, gives us an upside down u. All right. So let's graph this. And we want to make a table of values. Your calculator does that for you. So go ahead and typing that in. You should get this kind of graph right here. And you can go ahead and hit second calc, remember, to go ahead and find out your table. So at -3, it's -3, -1. 2 is -2, 3, -1 is -1, 3. And notice some symmetry that's going on here. See how this is -1 and that's -1? This is -3 and -3. This is 3. It doesn't have a partner, but guess what? If we went to -4 here, it would be 3 also. See the value right there? And that's what I mean about it being symmetric. We have points that are opposite, and we have evil twins of each other on opposite sides. All right, there's a line that goes right through the middle here that cuts us in half, and everything is exactly the same on each side. All right, our vertex would be down here at the bottom, and this would be opening up because this is a positive 1 in front. What is our y-intercept? Our y-intercept is that -1. See, it crosses at -1. That's where we would always find the y-intercept. All right. Which graph is this one? So it's positive, so we know right away it's not either of these two negative ones. We know it also goes through 2. So this one doesn't go through 2, and this one goes through 2. So we know already that C is the answer just by doing this. Now, of course, we can type this in our calculator and find out which one it is specifically. But if we know the different properties, we should be able to go ahead and find them no matter what. And C, of course, is our answer. All right. Consider the quadratic formula, 2 minus 4x plus x squared. Now notice they put it backwards. We can type it in the calculator this way if you want to type it in backwards so that it fits normally, that's fine. The calculator has no problem with that. We want to find the y-intercept, the axis of symmetry, and the vertex. All right. So I'm going to go through the different steps to do it algebraically, but again, you can do it with your calculator too. That's not a problem. So we're going to rearrange the functions just so we know what a, b, and c are. So a is 1, b is -4, and c is 2, just to make it look nicer so that we can plug it in our formula. Again, that's the quadratic term, linear term, constant term. Y-intercept is 2, that's the easy one. Might as well get that one out of the way, so we did the y-intercept, it's 2. Now, here's that formula, negative b over 2a. So we have to plug in the b is -4 and a is 1. So it is a -4. We do have that double negative going on here. So we do make that a positive 2. So the axis of symmetry has to go through that number, so it's x equals 2. And our coordinate then is also 2. Now you could have graphed that and figured out most of that yourself. Let's try it. We have this one here. And here you can go ahead and just make a table of values. You could do it by hand by plugging each value in. And see, here's our vertex here at 2, because it goes to the axis of symmetry. We just found that out here just a minute ago. 2 is our number. And when we plug 2 in, we can solve it and get -2 as an answer. All right. And we can go ahead and do the other points. But again, if we hit second graph on our calculator, we can go ahead and just see all this listed out. You don't have to do any of it by hand. So we can go ahead and take a look at the graph here. And now when we look at this graph, notice a bunch of things that we can find. Once we have this vertex, we know where the axis of symmetry is. This value here is really easy to take because it's just off of our point. And we can just go ahead and it's x equals 2 is this vertical line. It does need to be that whole thing, x equals 2, because it is a line. Do not just write the answer down of 2. That would be wrong. It has to be x equals 2. Our order pair is 2, -2. This is a minimum. Our graph, of course, opens up. 0, 2 is where we have a y-intercept. All right, so consider this equation here, and let's be better about this and just take a look at the graph. Instead of having to do it by hand, can you go back and do it by hand? Absolutely, if that's what you'd like to do, but it's a lot easier with the graph here. If we're looking at this graph, I can go ahead and say 1, 2, 3, 1, 2, 3, 4, 5, 6. So we have 3, -6 is our vertex. So that means our axis of symmetry is x equals 3. And our y-intercept is just this value back here, so 3. Y-intercept of 3, so it's not B. It's not D, so it's either A or C. Axis of symmetry is x equals 3, not -3. It's got to be C. Sure enough. And we can tell all of that just from our graph. So why wouldn't we graph it? All right, the same kind of thing here. Remember, we hit second calc to find out the exact values of the points. Again, we have that vertex at 3, 6, 3, -6, so 3, nope. Actually, here's the only one that has the right values. It's just matching them up. And again, they should be symmetric, right? So -5, -5, -2, -2. So D is our answer. All right, determine whether this function has a maximum or a minimum value. Now, if we look at this -1 here, we know that it opens up down. And I added the graph here just so that we can look at it because it's really easy to just graph it. But that negative would tell us that it opens down. And if it opens down, we're going to have a value on top. So that would be my maximum. So for this function, a is -1. And since it's -1, we know that it opens down. All right. Now we want to actually state the actual value. So we're going to go ahead and have to find that. Again, you go second calc in order to go ahead and use this. You want to use the maximum in the whole left right bound thing, and that should give you the value that's there. Now we know that it goes through the 1 here. That's what they just did here. They did it algebraically, but you can see that looking at the graph. And they plugged it in, and you get a value of 4, 1 comma 4. But using the calculator, that gives us the value of 1 comma 4. So the maximum value is 4. The vertex is 1 comma 4. So there's a little different terminology there, so just be careful of that. Now I want to state the domain and range. Now domain is the easy one. For all quadratics that we're dealing with in this chapter, the domain is all reals. Every x value can be entered in. This line keeps going on and on and on, and eventually I'll get to 5, and I'll get to 6, and I'll get to 7, and 10,000 it will eventually get to. So I can use all my x values. The range is the one that fluctuates. And it fluctuates because we have like for this one, we have a maximum value. The highest this one goes to is 4. And so our range is going to be all the values of y that are 4 or less. So we're going to say y is less than 4. Now they write it very interesting here. So the domain is all reals, so that's not any different. The range is all real numbers less than or equal to the maximum value. So they write it this way. Remember, we've talked about it, f of x is really just y. So if you wrote it as y is less than or equal to 4, that's what I would like to see. All right, so just y is less than or equal to 4. All right, this whole f of x is a set of f of x is less than, don't worry about that. Okay, just say y is less than or equal to 4. All right, maximum or minimum. So we're looking here. You can look at the value. It's a positive, so we know it opens up. So that means we have to have a minimum. Both or none, I don't know. All right, what's the minimum or maximum value? So we're over at -2, and we go down to -5. So the minimum value is that -5. What's the domain and range? Again, domain is all reals. So these two are out. And the range, here's that -5, but it's all the numbers that are bigger than -5 this time. So we're talking about greater than -5, so A. And that's what I have for you today.